To chapter 3.1. Chapter 3.1. Okay, so you're going to be the first generation of farmers that know calculus. First generation of farmers that know calculus. Farmers, because you're going to be growing stuff. You're going to be putting some stuff in the ground to get maximum yield. Right? So you're going to be scientific farmers. You're going to measure stuff and weigh things out and see how much dope you get. Yes. Nope. So what this graph will tell you when you do it in A is it'll tell you that if you use this concentration of fertilizer, whatever you use, you will get these many pounds of the good stuff. Okay? And you'll kind of home in on this because this is saying, hey, this is where I'm getting the most bang for the money. Right? There's another place here as well where your yield is going to be high. But then you'll have to do a trade-off between how much money you are spending on chemicals you're putting in the ground versus how much money you make on the street. Okay? You guys get the idea of what you're going to do when you become farmers or pot growers? Okay? All right, so let's really do the math now, okay? This was just to get your attention, and I'm sure I did some people's. So here's a nice, well, I'll take it down and let's see if it is nice or not. What this theorem is telling you is this, okay? It's telling you that if you've got an interval a and b, okay, a to b, and you've got a function that's continuous in this region. It's continuous in this region. Then the theorem is telling you that, hey, there's got to be a min in that interval and a max in that interval. All right, that's a big deal. Okay? And why do I say this is like the fundamental theorem of algebra? Okay, so Henry, you think you know what the FTA is? He's a stuff grower. He's a stuff grower.
That means there's always going to be a max and a minimum.
That's the extreme value theorem. Hello? The fundamental theorem of algebra. Does anybody know? Anybody? Felix? Anybody know? Janice? A2? Carmen? Not Carmen. Joanna? FTA? You guys are killing me. Okay, FTA is from pre-calc. It's from pre-calc. Yeah, what it tells you, listen up, okay? The fundamental theorem of algebra tells you that if you've got a polynomial that looks, say, like this, then the FTA tells you that there are 4 roots to that solution, which is what that number is. Big deal. How do you find them? That's where the work is. So in some ways, this extreme value theorem is like that. It tells you that there's a min and there's a max, but how do you go about finding it? Well, that's today's story. How are we going to find those? Okay? Guys get the idea? Okay, let's go do some work then. You know, so I was just telling my first period class that For some reason, I feel that in every period, I'm doing the maximum amount of work. Seriously. Seriously. I'm doing the maximum amount of work. I'm not, Michelle? Like how? I mean, if you are doing Facebook or what you might call yearbook, sorry. Yeah, Facebook. Yeah. If you're doing yearbook and you're doing chemistry and you're doing Spanish in my class, that doesn't count as, or SAT, that doesn't count as work. Today you are. For 2 weeks you've been SAT. You've been studying there for 2 weeks. Okay, now's my time to just chill here, okay? You guys do this. So what you're going to do is in Y1, let me get my... You're going to put this in Y1. Everybody with me on that? Okay? And then you're going to go find the minimum value. So you're going to go second calc min. Then you're going to go to the home screen and do a store alpha A. In other words, the minimum x value that your calculator is getting out for you, you're going to store it in A. Okay? So let's see you get that far. Minimum.
But there's two minimum. Wait.
Calc is in C2. Haha. Okay, everybody get a graph that looks like that?
Yes.
Okay, now you're going to go second calc min, number 3. You're going to move your cursor to where you think the minimum is, about there to the left of it, then to the right of it, enter, enter, and you'll get an answer that's like 2.44300009. Okay, something like that. Okay. Turns out that you might not get exactly what I got because there's a variation in the calculator. It depends on where you start out as well, so it won't give you the precise answer. Okay. Now you're going to go into the home screen. You're going to do second quit. You're going to do store, which is right above the on button, alpha A. So that x value has been stored. Okay. Now what I want to do is I want to calculate y prime, and I want to use that answer 2.43 whatever to find the derivative. But I don't want to do this derivative by hand. That's going to be nasty. Okay, so this is what you do on your calculator. You go into y equals. In y2, you go math 8, which is n deriv. Okay, n stands for numerical derivative. Numerical derivative of the function that is in y1. So you're going to go vars y vars function y1 comma x comma x. Okay, everybody made it there? Yes. Type it in exactly the way it is. Type it in the way exactly it is. Felix, you want my glasses?
Why do you need two x's?
Okay, I'll explain to you why you need two x's. Good question. The first x is telling the calculator that my function that is in y1, it's a function of the x variable. The second x is telling it that I don't want it only at one numerical value of x, I want it for all values of x. So it'll be like you'd be able to graph that. Okay? Everybody got this in y2? Okay, is everybody caught up with me on this? Okay, go into the home screen.
Y1, x.
Okay? Then you're going to go to vars, y vars, function, y2. And then you're going to put in alpha a in here. Okay? And so I'm getting a number that's like 10 to the minus 5. Okay? Which is like 0.0. Sorry?
I don't know the difference.
It's something 10 to the minus 5, 10 to the minus 6. Something like that. Maybe positive, maybe negative. Right. Okay. You can say that this is about 0. It's got too many zeros there after the decimal point, so it's like a 0. So then, for this one as well, this is approximately 0. So from these two examples, okay, we can conclude, okay, I want you to get down to the conclusion yourselves, okay? You guys need to write this conclusion down. What can you conclude? Anybody want to give me a conclusion? Anybody want to give me a conclusion? Yeah, Henry?
The derivative of minimum value is usually 0.
Okay, so kind of right, but not precise. It's not like it's the derivative of the minimum. What you want to say is that the derivative of a function at a min, it could even be a max, and we'll talk about that in a minute, could be a min or a max, is equal to 0. Okay, that's the conclusion from the two examples that we just did. Okay, so now we are getting to a point where we know how to find the min and max, because now we know how to find the x value where the min or max is happening, right? You find the derivative, you set it equal to 0, you solve, you get an x value out of there. Okay, so now we're getting a process of how to do things. Okay, so then you get a famous theorem. Well, no, wait, actually, let's do this one more example. This is a tricky one, okay? This is a tricky one. Well, it's not tricky, sorry, my bad. This is the untricky one. This one you should be able to do just by graphing. You guys know what the graph looks like? Sorry? It's a V. It's a V. Where's the minimum at? Nice. Okay. What can you say about the derivative of the function at that point? Sorry? dne. Why? Sharp turn, but mathematically, sharp turn is an English thing. Okay, let's do a math thing. Mathematically, derivative from the left is not equal to the derivative from the right. Okay, because the slope on this side here, what's the slope on this side here? And this side? So those two are not the same, and therefore the derivative does not exist. So now we're going to really modify our conclusion. Right? The conclusion before was that at a minimum or a maximum, the derivative is 0. In this case, the derivative dne. And then you come up with the concept of a critical number. So where these things happen, where the derivative is 0 or the derivative does not exist, the x value is called a critical number. And that's why they use the letter C. Is plural, and I want to kind of talk about what relative means. Okay, so you guys got this down? Yeah? So let's take a look at a function, okay, that kind of looks like, say, like this. And let's just pick an interval, okay? Let's pick an interval a to b, okay? And it's a closed interval. In other words, the function is defined at these two endpoints. So this point here